So the derivative of a function f with respect to the variable x is the function, this says f prime. I don't know if you can see that, but there's a little prime on there. We'll make it a little bigger. So it's f prime. We say f prime. That's how we indicate the derivative. So is the function f prime whose value at x, provided the limit exists, is the following. Right. This should look familiar. This should look familiar.
Oh, no, I've never
Let's talk similarities and differences here.
There's an X instead of an A.
There's an X instead of an A. There's one other difference. No, there was a limit already.
Oh, it's F prime.
Yes. We're just using the symbolism F prime in place of what? M, yes. But it's still the same thing. What did M represent? Way back in Algebra 1, yes. What does it represent in calculus, M, or F prime? The derivative, or the tangent line to the
Function, point.
to the function at a specific point, A or X or whatever. Okay, so this is the definition. This is something you've already memorized, the difference quotient. But this is an M over here, and this might be an A in your recollection, but it's the same thing. Okay. What we're doing in this case is now we're extending it. We're saying f prime of x is an actual function that models the whole set of tangent lines or slopes of the tangent lines of the function. Yeah. So what's that?
No.
All right. If f prime exists, we say that f is differentiable at x. You can throw that around if you're interchangeable with x. So talk about differentiability. And a function has a derivative at every point of its domain if, let's just say, of its domain is a differentiable function. So if it, this is kind of like our continuity definition. If a function is continuous at every point in its domain, then it's continuous. We call it a continuous function. And if a function is differentiable at every single point in its domain, we call it a differentiable function.
What is the derivative?
The derivative,
What's the purpose?
to find the instantaneous rate of change. That's the application, the physical application.
So we use the derivative to find.
The instantaneous rate of change at a point for a specific function. And the derivative is defined to be this limit as h approaches 0 of f of x plus h minus f of x over h. So if your college professor, as you're coming in, says, what is the definition of derivative? You'd say, well, it's the slope of the tangent line to the curve. And if they say, well, can you algebraically define it? You'd say, well, it's the limit as h approaches 0 of f of x plus h minus f of x over h. I go, oh, come on. You ready for calculus 2? Yes. Not necessarily. We'll get into that. Good question. Did you guys hear that question?
No.
The question was, it's a very good question. If a function is continuous everywhere, does that imply it's differentiable everywhere?
Yes.
So it's a very good question. We will answer that.
Can you say that again?
If a function is continuous everywhere, will it have a derivative at every point?
Yeah, that would make fun.
Uh, Good question. The answer is no. But, very good question. Now, if a function is differentiable everywhere, it will be continuous, but the vice versa is not true. if it's continuous, and we'll come up with examples for that. All right. This is just listing out different symbols. We do this all the time in mathematics. We have different symbols for the same thing. I don't have to tell you, you just need to know them all. So symbols of differentiation, we have f prime of x, which I just showed you. dy dx is another way. That comes from, I can give you the history on that. The d is replacing the delta sign. Remember that, the delta?
You like delta.
You like delta? Okay. What does delta represent? Change in y over dx. The d is replacing the delta x. So it's change in y over change in x. Okay? Change in y over change in x is also known in Algebra 1 as slope. So makes sense. dy dx. I like this notation. Yes. So y prime is another way to do it. So if you're not using f of x or g of x or h of x notation, you might just use y equals, and then y prime would be your derivative. This is not used terribly much in here, but df of x over dx. So this is just replacing y with f. And all those are symbols that are used. This is probably the most helpful as we get into the applications, the dy dx. And then the f prime of x is really nice because that's taking your function notation, and it's good when you have lots of different functions that are modeling different things and you're looking at their derivatives. So those two we'll use the most. Example 1 says find, that's kind of small, but that's find f prime of x. This whole unit is about finding the derivative. So find f prime of x using the definition of the derivative if f of x equals 2x cubed. And in this assignment, when I give it to you on Friday, it's in your syllabus. You could, think you'll take the whole time on the test and you don't want homework over the weekend, you could do it now. It will not confuse you. It won't confuse you. It's just going to reiterate what you've been doing. But they'll ask it using all different symbols. They're asking the same thing. They're just going to be cranking out different quotients for different functions. So that's what they're asking us to do here. It says find f prime using the definition of the derivative if f of x equals 2x cubed. Write the equation of the tangent line to this curve at x equals 2. So here's the thing, is it's asking us to find the derivative first. If it says find the derivative and it doesn't say at a specific point, I'm going to get a function in x, or whatever variable they use, not a number. If they ask find the derivative at the point x equals 2, you would just get the number, and that would represent the slope of the tangent line of 2. And we're going to do that, but first I'd ask you to find f prime of x. So I'm asking you specifically to find the derivative in terms of x. So we'll just do what the definition says. F prime of x, which is what I'm trying to find, is equal to limit as h approaches 0 of f of x plus h minus f of x over h. What is f of x plus h going to look like? I'm assuming at the top of your notes you have the formula written. So I'm not writing the formula again. 2x plus h cubed is correct. Minus, what is f of x? 2x cubed by substitution. I'd like you to go ahead and, with your partner, simplify this and evaluate the limit.
That's a problem.
You should have gotten 6x squared as your derivative. So, once, guys, you could go back and you may have to fight it. You're finding where you missed it, if you missed it. Okay. So let me finish this off, and then I can help you out if you need some help. So this is what you should get for the derivative function. So given that you got that, here's how we go from there. if I want to find the equation of the tangent line to this curve at x equals 2, I need to take my point slope form, which is y minus y1 equals m x minus x1, and I need to understand that m is simply f prime of a specific value of x. In this case, 2. So in place of m, I'm putting f prime of 2 and then x minus x1.
Is this the next step?
So let's go ahead and do this next step. We have y minus, how do I get y1?
2 and 0.
Yes, 2 to the original. In other words, it's f of 2 equals f prime of 2 x minus 2. So what is f of 2? 8 times 2 is 16. And the slope is f prime of 2 because the definition of the derivative, geometrically speaking, is it's the slope of the tangent line. So once you find the derivative, you plug in the specific x value that you want the slope of the tangent line at, and that's what it'll kick out. So f prime of 2 is equal to 6 times 2 squared, which is 24. So I'm going to replace the slope with 24 and then x minus 2, and now I'm done. So the formula is always going to be point slope form. You can replace y sub 1 with f of x if you want. Okay. I mean, if we wanted to, we could say, okay, let me move this over.
Arrows or best friend.
So if you want to, you could say, I'll do it in a different color here. Y minus f of x equals f prime of x, x minus x1. So guys,
There must be a nice additive ruler.
this is point slope form for the calculus student, right? F of x is your y1. F prime of x we now know is m, and x1 is always given. I did 2 cubed, which is 2 times 2 times 2, or 8 times 2. Original. There's a subtle difference here between these two, but there's a difference. F of x is talking about plugging into a different function than f prime of x. F prime of x will always be 1 degree, with polynomials is 1 degree less than that. All right.
I'm sorry.
Any other questions on that? I will ask you to do something like this on your test. You're going to actually find the slope of the tangent line. You're going to use the difference quotient to do that. So you'll do this process.
But once you get a test.
You will do the same process. It just won't be asked in terms of the derivative or f prime. It will be asked in terms of the slope of the tangent.
Yeah.
Did you want me to?
Yes.
We're doing this lesson.
All right. There's an alternate form of the derivative which you might like. You're welcome to use it. I guess this could potentially confuse you, but you guys are so sophisticated, I'm sure. So
That's a compliment.
if you'd like to, another way to write the definition of the derivative is f prime of a equals the limit as x approaches a of f of x minus f of a over x minus a. It's a little simpler to remember because it looks just like average rate of change, but instead we're taking this x value and just sliding that point closer to a. So it's kind of what you saw on the geometry sketchpad. You're sliding the points together. Rather than saying let h approach 0, you're saying just slide the two x coordinates together so that they overlap. So this is an alternate form. It does the same thing as the thing up above. Okay. So there are a couple questions in the homework that ask you to use the alternate form. You may like it and choose to use that as your definition. But this you won't use on the test. So this would be. This is supposed to be the square root of x. Back before I had math type. It says find. This is a y prime. It's not a graph on the screen. Find y prime using the alternate definition of the derivative if y equals square root of x. Write the equation of the normal line to this curve at x equals 4. So I'm asking you to do the same process we just did with a different formula, different function. Yeah, there's an algebraic trick we have to use with this. I'll show you what we're going to do here in a minute. So, here's my formula, right here. F prime of a equals limit as x approaches a of f of x minus f of a over x minus a. So let's go ahead and plug in f prime of is find of y prime using the alternate definition of the derivative if y equals square root of x. So f prime of a is the specific point at which I want the derivative, and in this case, what is that specific point? 4. So it's f prime of 4 equals the limit as x approaches 4, that's right, of f of x. What's f of x in this case? Root x minus f of 4, which is root 4, or 2, we'll do that in the next line, over x minus 2. So it looks like this. Limit as x approaches 4 of square root of x minus 2 over x minus 2. I'll explain it in just a minute here. F of 4 just means plug 4 in up here. So f of 4 equals square root of 4 or 2. That's how I'm getting the 2 right here. The bottom, oh yeah, that shouldn't be a 2. That should be a 4. Yes, that should be just a 4, because a is 4. All right, and then we're going to pause here for a moment. Okay, so we're going to multiply by, it is kind of like a conjugate form. And let's try square root of x plus 2. I mean, somehow we have to rewrite it. Maybe Colin's writing. Maybe we don't have too many choices. We cannot split it up. The only choices we have are to multiply by x plus 4 over x plus 4, maybe would be kind of like what we did with complex numbers, or root x plus 2 over root x plus 2. One or the other. So let's go ahead and see what happens here. We're going on an adventure. We may be going off the map here for a bit. We'll see. So root x times root x is x. What happens here? 2 root x minus 2 root x is 0, and then minus 4 all over x minus 4 square root of x plus 2. Do you see the wisdom in multiplying by root x plus 2 over root x plus 2 now? Something can't. This is a theme with our limits, right? If you plug in and you get an indeterminate form, you somehow have to rewrite it so something goes away.
They're reciprocals of each other.
So this goes away. We're left with limit as x approaches 4 of 1 over square root of x plus 2, and that plus 2 is not under the square root. So, and this is very good review. This is thinking about what you've been learning. You've been learning about. So in terms of the if substitution doesn't work, somehow you've got to rewrite it so something cancels out. And you did. You got it. I don't think you've ever seen this before. I don't think it's anything that's good. Even with square roots, you've seen this before.
Now with square roots, that's complex.
So limit as x approaches 4 of, let's drop the x approaches 4. Let's go ahead and just plug in 4. So it's 1 over square root of 4 plus 2, which equals 1/4. There we go. So now we're going to ask ourselves the question, what did the question ask in the first place? Okay. Find the normal line. Okay. So what did we just find? Slope of what line?
Normal line.
No, this isn't the normal line.
Tangent.
Tangent line.
Normal line is -4.
So slope of normal line is -4/1. It's the opposite reciprocal. So the equation of the line, y minus y1 equals m, x minus x1, is going to be whatever we get when we plug in y1 and x1. So let's leave a space for m. What was x? Oh, yeah. And that was point slope form. I was just replacing y1 with f of x notation and m with f prime notation. Same thing. So y1 in this case, what's y1 going to be? You got to go back up to the original formula. It was y equals square root of x, right? So y1 is going to be equal to square root of 4 or 2. So y1 is 2. X1 was 4, and the slope is -4. Box your answer, and you got it. This will be on the AP exam. It's on there every year. So in the multiple choice portion, they'll ask you to find slope of the tangent line, or equation of the tangent line, or slope of the normal line, or equation of the normal line. Yeah. No. No. Because we are only looking at the positive square root of 4. All right. Because that's what this is asking for. Positive square root of 4. There would be a plus or minus in front of it. You're thinking of when you have an equation like x squared equals 4. When you take the square root of each side, you've got to consider the plus or minus square root of 4. But I'm not asking for that. All right. One-sided derivatives. One-sided derivatives. One-sided derivatives.
That's true.
Okay, a function f of x is differentiable on AB if it has a derivative at every interior point of the interval, and if the limits, and we'll write these down, but we say a function f of x is differentiable on a closed interval AB if it has a derivative at every interior point. So that's just saying interior point would be anything between A and B, not necessarily including A and B. At the endpoints, it may not be differentiable. And if the limits, and this is a little plus sign on here, let me read it for you. There's a plus sign on there, so that's the limit as h approaches 0 from the right, and this is the limit as h approaches 0 from the left, exists at the endpoint. So I'll let you write that down, and I'm going to talk about what this means and why we have A in one and B in the other. Okay. Well, let's finish this up. So it says show that the following function has left and right hand derivatives at x equals 0, but no derivative at that point. I'm going to draw the picture first to demonstrate this, and then we'll do the algebra. So f of x equals x squared for x less than or equal to 0. If I plug in 0, I get 0. If I plug in -1, I get 1. -1 squared is 1. And if I plug in -2, I get 4. And so it looks like this to the left of 0. And then to the right of 0, it looks like this. If I plug in 0, I get 0. If I plug in 1, I get 2. If I plug in 2, I get 4. If I plug in 3, I get 6. So would you agree this is a continuous function based on its piecewise definedness? Definitely continuous. But I'm going to claim that the derivative does not exist at x equals 0. And there's a reason for that. We'll talk about that after we do the algebra here. So here we go. We're going to take this one first. Limit as h approaches 0 from the right of f of a plus h. What is a in this case? yeah, it's 0. So we have f of 0 plus h minus f of 0 over h. So the limit as h approaches 0 from the right. Let's go ahead and plug it in. So if I'm approaching 0 from the right, if I'm approaching 0 from the right, which function am I actually on? I'm on 2x's function. So I'm going to use 2x as my function as I evaluate this limit. Okay? Because I am on 2x's function as I'm approaching from the right. So it would look like this. 2 times 0 plus h minus 0 over h. This is going to tell me what I already know. You guys already caught on to this. I saw it in your clicker response. What is the derivative of this? Yeah, it's 2. How do you know that? Because it's a linear function. What's the slope of the linear function? 2. This is just saying, this is a derivative definition, right? Derivative is slope of the line. I already know the slope of the line. So this is limit as h approaches 0 from the right of 2h over h. H's cancel. There's nothing to plug 0 into. So that equals 2. So the right-hand derivative is 2. Do you think the left-hand derivative is going to be 2? I mean, what if I were to estimate? What do you think the left-hand derivative is right about here? Give me sine 2. Is it really positive 1? Okay, what is it right here? Is it ever going to be positive?
No.
Is there any way it's going to equal 2?
No.
What this says is that if they're not equal, the derivative doesn't exist. You could visually tell me that here. If this is positive derivative to the right, negative derivative to the left, not a chance. Okay, but we'll do the algebra anyway. So we have limit as h of f of 0 plus h minus f of 0 over h. So that limit is h approaches 0 from the left. Limit as h approaches 0 from the left. And you need to go ahead and plug this in. So we have 0 plus h we're plugging in here. So it's 0 plus h squared minus 0 over h. Can you tell what the derivative is actually? So this is limit as h approaches 0 from the left of h squared over h. One of the h's cancels. And if I plug in 0, I get 0. So it's approaching 0, if you will. We see that here. It's -1, and it's maybe -1/2. It's -1/4, right? It's approaching 0. But that's its limit. Remember, limit is what it approaches. So we show that the function has left and right hand derivatives, but no derivative at the point. So you should say there's no derivative at the point because the left and right hand derivatives are not equal.
So study session during summer.
Yeah.
It's just one of those games where you take everyone.